subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about the physics, and that is your class your 48 that we have to discuss here. So on the same way, if I'm going to ahead in the detail about it, we have to start with the unit 6, which is work, energy and power. This is the first class of this unit, where we had completed your, this is the part 1 for class 11. So we had done your unit 1, unit 2, unit 3, unit 4 respectively, unit 5, and now we discuss about unit 6, that is the first is your work, energy and power. So first we'll discuss about the introduction. Okay, let's go for the same. In terms of introduction here, the term here work and energy and power that are frequently used in everyday language, and a farmer that ploughing in the field, construction worker that carrying bricks, and a student studying for a competitive examination, an artist that playing a beautiful painting a beautiful landscape, all are said to be working. In physics, however, the word work covers a definite and a precise meaning. Somebody who has the capacity to work, that is for 14 to 16 hours day, is said to have a large stamina or energy. We admire long distance runner for her stamina or energy as well. On the same way, with the same that we admire the long distance runner for the stamina or energy, thus our capacity to do work. In physics too, the term energy is related to work in the sense, but as said above, that the term work itself is defined much more precisely. The word power is used in everyday life with different shades of meaning, and different shades of meaning. And in the karate or boxing, we talk of powerful punches. They are delivered at the great speed. The shade of the meaning is close the meaning of the word power used in the physics. We shall find that there is at best of a loose correction between the physical definition and the psychological picture, where the term that generate in our mind. The aim of this chapter is to develop and understand of these three physical quantities. Before we proceed to this task, we need to develop the mathematical prerequisite, namely the scalar product of the vector as well. So first we'll discuss about the scalar vector that is on the detail here. So let's go for the same. So in the same way, for the discussing about the scalar product, so we are on the same way for the scalar product. We have learned about the vector and their uses in this chapter of the physical quantities like displacement, velocity, acceleration, forces, etc., that are vectors here. So we have also learned how vectors added or subtracted. We know that about we don't need to know about the multiplied. There are the two ways of the multiplying that we shall come across. One way known by the scalar product, and that gives us scalar form, two vectors, and the other had a vector product that produces a new vector from two vectors. So shall we discuss that in the vector product in the next coming chapter, that most probably your chapter 7 here that we discuss. So hence up the scalar product of the two vectors, the scalar product of two vectors a and b, that is denoted by a dot your b, that is being denoted here. So for that, a dot b that has been defined, just we go for it, is your a dot b equals to ab cos theta. So a dot b equals to ab cos theta. where the theta is the angle between the two vectors as has been shown here. So since a, b and cos theta that are scalars, the dot product of a and b is a scalar quantity, and each vector of a and b has a direction, but their scalar product does not have a direction. So we go for a dot b equals to a dot b, a b cos theta equals to b a cos theta. That comes under in it. So geometrically b cos theta, that is a proportion of b onto a, and in that a cos here is a projection of a onto b, and where a dot b is a product of the magnitude of a and the component of b that along with a. Alternatively, it is a product of the magnitude of b and the component of a along b. Here the equation that shows the scalar product that follows the commutative law, that is a dot b equals to a b dot a, that is known as for the commutative law. So a dot b equals to b dot a, that is comes under your commutative law, and that is you had learned in the last classes as well as in your 12th class as well, board that you had done. So in the commutative law, the scalar product obeys the distributive law. So let's go for the same. So here for the deep knowledge about it, let's figure it out. So here we go. Scalar product obeys the distributive law. So on the same way, if you further go ahead, a dot b plus c equals to a dot b plus a dot c. Further, lambda a dot lambda b equals to lambda a dot b. We have lambda is a real number. Lambda, it tends to be real number. Okay, so here the proofs on the above equation that are left to be as shown on the exercise, and for unit vector it will be your ijk for unit vector. We have I dot I equals to j dot j equals to k equals to 1. I dot j equals to j dot I k equals to k dot I equals to 0. So gives it here, you have to give the two vectors here. Let's go for it. For that, A, this is angle theta, this is B. This is the first figure. Second is A, B cos theta, this is B, this is theta. And this is here for this. Let's go for another one. A theta A cos theta. This is B. Okay, so here the first one for this, the scalar product of the two vectors A and B is a scalar. For the second, that is A dot B equals to AB cos theta. For B cos theta, that is the projection of B onto A, and the C, the A cos theta, is the projection of A onto B. Let's figure it out with the same. A equals to AXI cap. Thus here the two vectors A by J cap plus AZ K cap. For B, it is equals to BXI cap plus BYJ cap plus BZ K cap. So their scalar product A dot B equals to AXI cap plus AYJ cap plus AZK cap dot BXI cap plus BYJ cap plus BZK cap, that is equals to AX plus AY BY plus AZ BZ. Okay, so from the definitions of scalar product that we have here, it has been A dot A equals to AX plus AY plus AY plus AZ, that is equals to A square equals to AX square plus AY square plus AZ square. Since A dot A equals to mod A cos 0 AC square. So A dot B equals to 0, which is if A and B are perpendicular. So let's go for the question here, which is we have here, that is of course being an important one. The question is find the angle between the force unit and the displacement unit. Also find the projection of F and D. So no way, we go for it and we'll figure it out as well. So let's have it. So the question first and then the solution as well. So here we're gonna end up here only. We'll discuss the rest in the next coming class. The question is find the angle between force F equals to 3I cap plus 4J cap plus minus 5K cap unit and displacement D equals to 5I cap plus 4J cap minus 3K cap unit. Also find the projection of F and D. Let's go for the same. So FD equals to Fx dx, Fy dy plus Fz dz equals to 3 5 plus 4 into 4 plus minus 5 into 3 is equals to 16 unit. Now for hence F and FD. So for F and D, here F dot D equals to FD cos theta equals to 16 unit. Now F dot F equals to F square equals to F x square plus Fy square plus Fz square equals to 9 plus 16 plus 25 equals to 50 unit. Now if we go for and D, D square equals to dx square plus dy square plus dz square equals to 25 plus 16 plus 9, which is equals to 50 unit. So cos theta equals to 16 upon under root 50 equals to 16 upon 50, 0.32. Theta equals to cos inverse 0.32. That is the theta. We get it, found it out. So that is what we have to end up here only. We'll take the next in the next coming class, that is about the motions of work in the kinetic energy, the work energy theorem as well. So stay tuned with us and please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Please like, share and subscribe so that many and maximum people can get the information at once. Thank you.